Good morning and welcome to Integrated Science. So previously we have been talking about how work and energy are connected and how we can look at a system and figure out what is the kinetic energy moving through the system and what is the potential energy moving through the system. And then we can look at the whole system and say, what does the law of conservation of energy have to do with how energy is moving from one form of energy to the next? And so then we talked about thermodynamics and how heat is a process or a byproduct of energy. So normally when you have two objects doing something creating energy, it is also creating heat. And so we're going to move into kind of the final portion of this unit where we're going to talk about how wave energy, how things that are micro level we can discuss, and how energy is being transferred through those systems. So we're first going to start with just the simple static electricity, which is normally just a result of two objects coming in contact and the release of that spark of energy. And so once again, it still has to do with that heat resource that we're going to be kind of discussing. And so to do that, we have to kind of start from the beginning with our little portion of chemistry, if you want to think about it that way for this class. So in order to understand static electricity, we have to understand the subatomic particles of an element. And so first off, an element is just the simplest form of matter, meaning that when we look at how these particles are broken down, you can jump into talking about molecules and compounds, but the simplest form is just an element, meaning that what is the amount of protons, the amount of neutrons, and the amount of electrons that are going to be kind of in that element. So it's the simplest form. So we have the periodic table of elements that we use to kind of help decipher these different elements, and it goes all the way from highly reactive elements here on the left hand side to very, very stable elements on the right hand side, meaning that these normally bond with some other element on the periodic table because they are looking for perfect bond that's going to allow them to have a full count of electrons. So when we're talking about static electricity, we're also kind of looking back at these subatomic particles, which is here atoms, our smallest piece of an element containing all the properties of that element, meaning that all hydrogen atoms look the same, all lithium atoms look the same. If we jump over here, all carbon, all nitrogen, neon, they all have the same amount of protons, neutrons, and electrons. And sometimes you'll hear me refer to them as subatomic particles. And these are our subatomic particles. So the components of our atom is, we're going to start with the nucleus, which houses both the proton and the neutron. So it's like the center of our atom. And within there, it contains both our protons and our neutrons. And it's important to understand that these subatomic particles have a particular charge to them, meaning that protons are always positively charged particles. That means that they have a little plus sign next to them. They're ready to give energy, and neutrons are actually uncharged. They do not have any atomic particle charge, and that kind of allows the protons and the neutrons to stay within the nucleus. Is that exception that the protons have positive, the neutrons have a neutral, and then outside of the nucleus is our electrons, and those are the ones that we're going to be paying attention to because they are the ones that are giving us that electrical shock or that energy that is being burst through. So electrons have negative charge, meaning that they're always willing to accept a charge towards them. And so they orbit outside of the nucleus in what is normally called the electron cloud. They all have orbits around them. So just think like the planets in our solar system have orbits. This is kind of that same idea, just on a really, 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 really small scale. So electrons have a negative charge and they orbit around the nucleus of the atom. And as they do that, they exchange, or they are kind of connected connected with our protons having a positive and our electron having a negative, and that kind of keeps them in this like cycle or circuit. And that's what we're going to kind of be getting to, is what are these circuits that kind of change the way that we use a lot of electronics in devices. So valence electrons are the ones that we're going to be mostly talking about, because they're the electrons that are on the outermost shell that are creating or exchanging energy for things to happen. So valence electrons are the outermost ring of an electron in an atom. I'm going to give you this example there. You can see this is what technically a atom would look like with our protons and neutrons. It's very 3D. Hard to draw 3D, so a lot of times we'll go to 2D, which is this is our diagrams that we would draw in class. So just to kind of understand how electrons flow around, let's see if I can get this to play for us. So first off, electron flow. Electricity is created as electrons collide and transfer from atom to atom, meaning that as they move around, they are going to collide and they create almost like a static spark. So if you've ever like taken a balloon and like rubbed it against your head and then tried to put it on the wall, or if you are wearing socks and you like scoot across the carpet and then get behind someone and try to shock them, you are charging, you are allowing those electrons to gain positive charges from the protons, because you're like smashing them together, causing them to do some energy, and then you go up and touch someone and you physically change it and shock them. So you are becoming a conductor of electricity as you touch something sometimes, and that's going to happen quite a bit, especially in the winter when the atmosphere is much drier. We kind of lose our humidity, and that is definitely when you can get a lot of electrical static charges kind of like popping through. So once again, this is created just because those electrons are colliding. So a static charge is a qualitative observation, meaning that we can actually look at an object and sometimes see that spark. I doing laundry a lot of times, once again, taking laundry out and then like trying to fold it, sometimes you can see those little sparks coming through. There's other times that you could see this just by like an outlet. Sometimes if you plug something in, you can see that blue spark kind of come through just a little bit. These are qualitative. We can observe them. So we have spent a great deal of time this year talking about quantitative by using our equations, how to find kinetic energy, how to find potential energy, the work, speed, distance, all those things. Static is a qualitative, so we're going to make observations. So we see a spark come from that. So the study of electrical charges, where charges from walking across the carpet, lightning, static cling, these are all observations. We can make an observation about them and then describe what you saw. Well, it caused the other object to stick to it, or it fell immediately after the energy source was taken away. So all these different observations are qualitative. Observations. So as we go through, we're going to make lots of different observations. Excess charges is released when an object is grounded, meaning that when it is connected to a conductor, it is going to let that charge kind of move out. So grounded equals connected to earth by a conductor like a copper wire. So just think like it is put into the ground. Most of houses have some kind of grounded wire in case if your house were to get hit by a lightning bolt, it would send the electricity down and out through the ground, as opposed to like in your house where it could be really, really, really devastating. And we have most of them also in appliances, especially newer homes are going to have the three-prong electrical, and that third one is the grounded. You can see the difference. This is the older ones. These are the much newer ones, meaning that it's going to stop a charge if it gets surged too much through. And for those of you that know me very well know that anytime I can plug in something about dinosaurs or space, I'm going to do it. And so if you've ever seen Jurassic Park, this is a great example. The park is wired with electrical fences all around them, and in one of the scenes the little boy Timmy is on the wire fence and they turn the electricity on, and since he is up in the air and not having like a body part to the ground, he is completely electrified and then gets fallen back and so forth, and they resuscitate Timmy. He makes it, but he is one that is not grounded. And so, but somewhere in Jurassic Park they probably have a wire in case, like, if electricity gets surged through the system, it would be stopped somewhere along the line so that they wouldn't go through like a whole rolling blackout. So one of the other things that we're going to talk about is how this motion of energy can be replaced, which is just the motion of static. And that is, the charge is at rest, meaning that it has potential energy. It's just sitting there. And then energy is surged through the system that allows it to move into kinetic energy. So the charge is at rest, stays until it is discharged to air or other objects, meaning that when something comes across it and those electrons are positively, or they are charged up, they're going to shoot the energy through the system. Different forms of current, electricity when charged move. Different form current, electricity where charges move. So kind of think of this as well, let me read this and I'll explain it. So static electricity is an unbalance between negative and positive charges in our objects. So meaning that it's potentially just waiting for something to run into it or be applied to it to change it to a positive. So once again, static electricity is an unbalance between the negative and positive charges in objects. Electrical charge is a fundamental property of energy, meaning that it can be moved back and forth, back and forth. And so these two metal objects here were probably had potential energy, and then there was a surge of heat moved through the system and it caused this electrical spark. So we can think of it in simple things such as like cell phones, our laptops, our Chromebooks, is circuits. And so we charge our Chromebook or we charge our phone, and what that is it's a circuit that's in there. So if we think about just even our outlets again, if I were to take a meter reader to it, one would heat up with energy and the other wouldn't, meaning that it goes through a system in a circular process, that it's going to exchange positive energy with negative energy, and positive energy with negative energy, kinetic energy to potential energy, kinetic energy to potential energy. So it goes through this system. Think of it as like batteries. If you've ever had to change like a battery in a toy or a remote, you have to have the positives and the negatives together because it's a full circuit. It wants to be able to travel around the circuit in order for those electrons to exchange that energy. And so that's what this is talking about, electrical current. It's a system of conductors and components forming a complete path of current to travel. And we normally use these terms to describe a volt, a current, a resistance. And so once again, it's the idea that you are creating a circular current and exchanging the energy from positive to negative, kinetic to potential, kinetic to potential. So we're going to take a look at this a little bit further and how static electricity can change how the protons and the electrons just interact with that positive and those negative charges. So hopefully this was helpful.